All right, let's do this, guys. Lesson 10.2.3, how can I solve it? Multiple methods for solving equations. I'm here to the bottom right of this screen and trying a different format here. Instead of printing this out and doing this on with pen and paper like you guys are probably doing it, I'm doing it on the computer here. I think I might be able to see this a little bit more clearly, and hopefully this works out. We'll just see how it goes, right? Always try different things, always experiment, keep iterating, keep improving, and that's kind of how the world works, and that's how you can dig in and make things happen, okay? So we've been doing a lot of solving the past week or so. That's kind of the reason why we have these 3 lessons this week. I think it was Tuesday, Thursday, Friday you had lessons, and you also had Chapter 9 review on Monday, so make sure you've done that too. But just a lot of just kind of solving equations. And these aren't super complicated. I don't think the last couple lessons. Some of it may have been review. You should have kind of known the whole multiply by the least common denominator or least common multiple denominator. So sort of fraction busting should have kind of been a review. This will feel like maybe a tiny bit of review too, but it's going to get you to be able to solve something a lot more complicated. Something like this, which I would imagine for the majority of you guys is something, a big, scary problem. But the goal is you want to get to something like this to be able to solve something like this. So we need to look at some other ways, more ways to solve equations, and how do we solve that equation right there as easily as possible. So let's get into it. Multiple methods for solving equations, starting now. So far in this course, you have developed several different methods for solving equations, such as adding numbers and variables to both sides of an equation, or multiplying each term by a number to eliminate fractions. But how would you solve a complicated equation, such as the one shown below? Well, hey, that's what I was just plugging a second ago. This is scary. This is crazy. So there are ways to do this. You could solve by undoing this one, and undoing is doing the opposite of PEMDAS. Keep kind of writing this one down, but it's going to be helpful for you. So perhaps you solve this one. The opposite of PEMDAS is SADMAP, right? SADMAP. So remember, I've said this a few times here, but it's an important thing to keep in mind. It's probably the best way I can imagine, at least for me as a teacher, to teach you this, is that when you plug in, right, if we were to plug in for x here, you'd have to add 5 to it first, and then you'd have to take the absolute value because you do parentheses first, right? So that's grouping, and then you do the square root, right? Because that's over it next. So you kind of do the order of operations. PEMDAS solving is the opposite of that. It's SADMAP, okay? SADMAP for solving. So for a problem like this, my quickest way to teach you how to do a problem like this would actually just be to follow SADMAP. What's the last thing that happens to this here? Oh, well, we got to deal with this addition and subtraction, get rid of it. Subtract the 4 from both sides. That makes things more simple. And this equation actually is more simple than just following a SADMAP direction like this, which is part of the reason why we need to learn these other solving skills a little bit later. So I'm actually going to cross this out here. Don't think about SADMAP at all. Think about what we're doing today, which is going to be different methods to solve an equation, right? I can't just give you this list, right? I wish life were so simple. Just follow the directions of solving, getting rid of addition and subtraction first, and getting rid of division and multiplication, and then exponent in parentheses, but it's more complicated than that because this is a much more complicated problem, so we need to get into this and see what it's going to take to solve a problem like that. So by looking at equations in different ways, you'll be able to solve complicated equations quickly and easily. Yes, I want you to get that far. These new approaches will also allow you to solve new equations you have not studied yet before. As you solve equations in today's lesson, ask your teammates these questions. How can you see it? Is there another way? Okay, so we'll question ourselves, right? We'll question what we're doing here. Always want to view what we're doing with a critical eye here in high school. All right, let's keep going here. Wow, they're really beating this over the head with us here, but just in a few more lessons, you're going to be able to solve that. Don't worry, we're not going to solve that today. This equation is complex and will require you to look at solving an equation in new ways, different methods, different approaches to it. To be prepared for other strange and unfamiliar equations, you will first examine all the solving tools you currently have by solving a comparatively easier equation, and this is one here. So there are multiple ways you could solve this equation right here. 4 times the quantity x plus 3 equal to 20, right? And you might be thinking off the top of your head, oh, I can do one thing first and then a few other things after that. Or, you know what, I can do something else. Kind of the first step here is up to you, right? And this is why I want you to learn. We're going to go over 3 ways, 3 lessons here today. 3 ways to solve something like this, because you can kind of choose what direction you want to go with it. First step here, well, it's going to be different in one 2, and 3. We'll have 3 different ways to solve. That's sort of what today is going to be like. And so when we say, hey, I'm going to solve it by this approach, hopefully you understand what that approach is and you would know what to do. So we have 3 different ways, and there'll be a different first step each time. And maybe we can talk about this afterwards. Once we get the 3 ways, we can talk about what your first step would be, being trying way number 1 or way number 2 or way number 3, okay? So what it says down here, with your team, solve 4 times the quantity x plus 3 equals 20 for x, at least 2 different ways. Explain how you found x. In each case, be prepared to share your explanations for class, okay? So in a normal year, you'd have your group, right? You'd be working with your group, and I'm sure every table could come up with maybe 2 different ways to get to what x has to equal here. But since we don't have that this year, we're going to go through them together. And step 1 is going to teach us what one of the ways is to solve something. And this is called solving by rewriting, which we've already kind of talked about, right? We talked about that 2 lessons ago before fraction busting. Remember that one? What was solving by rewriting? Remember that? That's right. Solving by rewriting is to take an equation and rewriting it in a simpler, easier to solve equation. So David wants to find x in this equation 4 times the quantity x plus 3 equal to 20. And he said, I can rewrite this equation by distributing the 4. Sure, we have parentheses here. That's pretty complicated. Might as well distribute the 4 on the left side and do what the mathematics is telling us to do on the left side, right? If the mathematics is saying that, hey, this 4 is supposed to distribute into the x term and the 3 term, then you might as well have that 4 distribute over the addition of distributive property of multiplication over addition, because then it's rewritten, and then at that point you might solve it. Okay, so this is solving by rewriting right here. Step 1, distribute, right? Do the math, right? Rewriting kind of means do the math on one side. Do the math that's being suggested, right? Take the 4, multiply it by x plus 3. So after distributing, what should this new equation be? Solve this equation, use David's method. Well, after distributing, we would have 4x plus 12, and that'd be equal to 20. And then we got to solve this equation using David's method. Well, I think we know what to do right there. Here we actually can follow our SADMEP solving rules here, okay? So what's the, we got left side here. We want to isolate what x is. So we got to start with addition, because addition is going to come before multiplication in SADMEP. So let's get rid of that. And to get rid of addition, we got to do our inverse operation, which is subtraction. So we'll subtract 12 from both sides to isolate the 4x term on the left side. So we get 4x, and that's equal to 8. And SADMEP, right? Well, there's nothing else there. So we remember, so A becomes before M in SADMEP. So, right, remember PEMDAS spelled backwards. That's what I'm doing. We're doing PEMDAS spelled backwards to solve. So then, right, the only other operation we got to get rid of is the multiplication mapping here, which comes near the end of SADMEP. So to get rid of the multiplication, the opposite of that is division, and we get our answer. Nice and easy. We got what we want, which is our answer. We've found x by itself, and we've done the right thing. But if we can get x by itself, x equal to something, then we've gotten it in the right place and we got our answer here. Okay, so that's step 1, is solving by rewriting, right? Do the math that's being suggested by the side of the problem, and then once you do that math out, then, hey, you can solve it using SADMEP. You can solve it using your normal solving skills. Okay, next one is number 2. Skill number 2 is going to be solving by undoing. Juan says, I see the whole thing a different way. Here's how he explains his approach to solving 4 times the quantity of x plus 3 equal to 20, which he calls undoing. Instead of distributing first, I want to eliminate 4 from the left side by undoing the multiplication. Okay, interesting. So instead of doing the math, right, doing the math here and actually distributing, right, he doesn't do that. He doesn't do this here. Okay, he says, why bother with actually doing the math out on the left side and then trying to solve, right, distributing here? Let's skip ahead here and solving by undoing. Let's get rid of the 4. So let's see, I want to eliminate the 4 from the left side of undoing multiplication. So solving by undoing is getting rid of things that don't really need to be there. And that's the 4 in this situation. That doesn't really need to be there. So let's think about that now. We got 4 times the quantity x plus 3 equals 20. And the question here for part A is what can Juan do to both sides of the equation to remove the 4? And why does this work? Well, if you got your thinking cap on, if 4 is being multiplied to x plus 3, then the way to get rid of that 4 is we just need to divide, right? What if we did 4 times x plus 3 and we got a product where 4 is a factor? Then we can just divide that by 4 to just get rid of that 4 factor right there. We can divide, and you need to do that to both sides, right? Divide both. To remove a 4 factor, we need to divide both sides of the equal sign. Remember, equal means the two sides are balanced. They represent the same thing, just written differently. So if we divide one side by 4, we need to divide the other side by 4. To keep the equation balanced. Okay, solve the equation using Juan's method. Well, let's go ahead and let's move this down here. What we would get as a result would be x plus 3 equal to, and 20 divided by 4 is 5. And at this point, there's just one step remaining to isolating what x has to be, and that's subtracting 3 from both sides. And I know obviously you can do that in your head, but when you just want to follow the algorithms, right? Follow the patterns, and it might just be faster to do the workout themselves, because obviously 2 plus 3 equals 5. So you could have done it in your head, but subtract 3 from both sides, and you get x equals 2. Okay, so we know it's correct because the last equation we got the same thing too. Okay, so that is step number 2, which is solving by undoing. That is method number 2. 3 different ways to solve undoing. All right, why is this appropriate? Why is it appropriate for this method to be called undoing? And that I'm just going to refer back to what we said up here, which is this, right? We're getting rid of parts of an equation that don't need to be there, right? So what we're kind of doing is we're slowly undoing the way the equation is written. Okay, and the way we're doing that, just think about the way we're undoing too. So where this operation was multiplication and we undid it by division. And this option here, this was also solving by undoing technically, because the operation happened in x was addition. We undo it by subtraction. So we might want to say something about that here, is that we're undoing, or the way we're undoing by doing the opposite operations in a problem. So what we're doing, we're kind of just undoing what the problem is telling us to do. And we're undoing this multiplication here by division. Undoing what the problem is set up as, we're undoing this addition by subtraction. So that's why it's called undoing. Finally, third thing to kind of review today is solving by looking inside. That's going to be the third one. So I'll just go ahead and write it up here on our list here, just so to be perfectly clear, you're getting 3 different skills here today. Rewriting, which is again, kind of doing the math out, and then maybe you end up in a form that's easier to solve. So actually doing distribution, if you see it up here. Undoing means just getting rid of pieces right away. Immediately start the problem, not rewriting it, just getting rid of pieces of the equation. And then the third thing is going to be looking inside. And looking inside, every year people ask me, well, what is the deal with looking inside? Isn't this just kind of guessing and checking? And yeah, it kind of is, right? Looking inside is kind of doing it in your head a little bit here, because you could totally do something like this in your head. Similar to above here, what I was just telling to you above is that here you could do this problem here, not by undoing, not by taking 3 away from both sides, but just asking yourself, so what does x have to represent? What does it have to be if we add 3 to it to become 5, right? A little mental math right here. And x would have to be 2. By looking inside the problem, you just know the answer, right? X, the only value that when we add 3 to it's 5 is 2. So 2 is going to be the answer there. So that's a little preview of what looking inside is, but let's talk about it right now. And Kenya's talking about this now. Kenya said, I solved David's equation in a much quicker way. She solved the equation 4 times the quantity of x plus 3 equal to 20 with an approach she calls looking inside. Here's how she described her thinking. I think about everything inside parentheses as a group. Okay, so I'm going to underline that. We're looking inside parentheses as a group, right? After the parentheses group all that stuff together. After all, the parentheses, it groups it, right? It groups that stuff together. I think of the contents, the parentheses must be equal to 5. And I agree with Kenya right here, because if we just look at this equation here, what's going to get us from 4 to 20? What does x plus 3 have to represent? Well, it has to represent 5, because 4 times 5 equals 20. Right? So we can think about x plus 3 being interchangeable with a 5 right here. We'd have to substitute 5 in there for x plus 3 in order to get us to 20. So that's just going to mean that x plus 3 would have to represent 5. So just by looking inside of parentheses, what must be this parentheses equal? Well, it must equal this, must equal 5. And this is kind of what you can say in part A. So I'm sort of justifying this here, that the only way we can get from 4 to 20 is by multiplying by 5. So if we're multiplying 4 times by x plus 3 to get to 20, then x plus 3 must equal 5. Write an equation that states the contents of the parentheses must equal 5 and solve the equation. This is called the looking inside method here. So we can do this by what I did a little bit earlier, which is just this right here. So inside the parentheses is x plus 3, and that's got to equal 5 again, because 4 times 5 is giving it 20. And do we get the same answer? Yeah, we can. X has got to be 2 in this situation. So we totally get, by looking inside here, 2 plus 3 is what gets us to 5. So it gets the same answer. We can write our final answer here and circle it right there. We got the same answer. Cool. So 3 methods. You're going to read about 3 methods later, but we've already kind of taken notes on it here. Just notice here we had different first steps for all 3 of these methods here. Rewriting, again, is kind of when you do the math out, right? Do the math out, and you might end up with the equation in a form where it's easier to solve than maybe what you see right here, because you might not know what to do at this point. So you see distribution, distribute. You see something being taken to the second power, you might as well take it to the second power. So just follow the operations that it says here, and then you might end up in a form you might be able to solve. That's rewriting. So step 1, we distributed here. Step 2, the first step of undoing, is that we got rid of the 4. We divided both sides. This is sort of undoing, is kind of inverse operations, doing the opposite. So I might write that right here. Undoing is doing the opposite. And finally, step 3, looking inside, is finding, right? We just looked inside, parentheses, looking inside of grouping and saying what that group has to represent to make the equation true. So this one here, we didn't divide by 4 both sides. We didn't distribute the 4. We just said x plus 3 must represent 5, and that was our first step. Okay, so it says the 3 methods here. Find the math notes box for this lesson, read it with your team, match the names of the appropriate approaches on the left with the examples on the right. We have rewriting, we have looking inside, we have undoing. Hopefully you get what those 3 things are right now. We just talked about them. I think I explained it relatively well too. So if you watch the whole video, I think you're just like, I get this. This isn't too hard. But just in case, you just make sure you read this down here below. This is methods to solve single variable equations. Here are the 3 different methods that we talk about here in this book. And then other books talk about these too, but different books focus on different things. This is what your book focuses on here. Okay, rewriting. Rewriting means just using the algebraic techniques to rewrite the equation. So again, you have the equation written some way. Is there some algebra being are you being guided somewhere to like do something? So if you are, 5 times the quantity x minus 1, you do the algebra out. 5 times by x minus 1, distribute, and then you can solve, right? Kind of by undoing later. This will often involve using a distributive property to get rid of parentheses. Also maybe squaring something, a binomial squared, writing it as a trinomial without parentheses. So kind of getting rid of parentheses, rewriting. Then you solve the equation using the methods you know. Looking inside means choosing a part of the equation that includes the variable. And then seeing how that variable is grouped and seeing what it must be. So in this same problem here, we choose part with the parentheses. So make sure it includes all, this is good, all occurrences of the variable. There's only one occurrence of the variable there, so we got to circle this, and we know that this has to equal 3 because 5 times 3 is how we get to 15 down here. Not negative, I'm gonna get rid of that. What must this equation equal to make the equation true, right? And so it's just sort of an informal way of solving, right? X plus 1's got to equal 3, so that means x has to be 4, because 4 minus 1 would equal 3. So you can either write a simpler equation like this, right? X minus 1 equals 3, or you can just ask yourself, what must x equal, and that part of the equation equal, to make the equation true. And finally, starting by undoing, this is solving by doing inverse operations. That's another textbook calls this, so I'll write this out here. inverse operations. Inverse kind of means opposite in math, doing the opposite. Similar things, but completely different, right? Does the opposite thing. So start by doing the last operation that was done to the variable. This will help give you a simpler equation, which you can solve either by undoing again or with some other approach. So the last thing that happens to x here, so first x gets 1 taken away from it. The last thing that would happen to x is the distribution part, the 5. So what you can do to get rid of that first is divide this side by 5 and divide that side by 5. So this is the one where oftentimes you guys solve this way. You solve by undoing because, right, and then I get my 3 down there, and then I get x minus 1 here, so I can sort of jump to this step right here. But often you solve this because you're just so used to this. Well, what's the opposite of multiplication? Division, right? It's very orderly and a neat way to solve. So let's see what they have up here to see if we can get this. So solving by rewriting. Okay, let's see what we got here. It's probably not going to be 1. That'd be too easy for us if these matched up. If 3 plus the quantity 4n minus 4 equals to 12, then 4n minus 4 must equal to 9. That looks like it's got to be what? Looking inside. Yes. So this is the one we're saying that if 4n minus 4, if that were 9, right, then 3 plus 9 would equal 12. That's just sort of looking really quickly. I got a quantity here, 3. What's being added to it is this expression, and then we get 12 as the result. So 4n minus 4 has to equal 9. That is looking inside. That's looking inside. This occurrence of the variable here in the grouping, that whole grouping has to equal 9 in order to get us from 3 to 12. And that's looking inside. Okay, part 2, subtracting is the opposite of adding. So for the equation, this equation, I can start by subtracting 4 from both sides. Cool. So doing the opposite, that is undoing, my friends. That's totally undoing. Okay, the last thing that happens to x in this situation is the plus 4, right? You want to start away from x. SADMEP for solving. So you want to get rid of, there's kind of, well, this is some subtraction in here, but this subtraction's in parentheses. That's the difference between subtraction that you start with solving first and the one you save for the last. So parentheses is at the end of SADMEP, or PEMDAS spelled backwards, right? So the first thing you get rid of is this addition, because that's early in SADMEP. It's the second thing to get rid of, right? So subtract 4 from both sides, divide both sides by 3, and then you can deal with the parentheses. You can add 7 to both sides. So this one is undoing, and hopefully you got that one right there. And I didn't actually circle this one up top, but I can do that now. Boom. And finally, so just by process of elimination, this would have to be rewriting, but we'll read it to make sure we all get it. So this problem might be easier if I turned 4 times by 2x minus 3 into 8x minus 12. Yeah, it's sort of just doing what the algebra is telling you to do here. Take that 4 outside of parentheses. What do? Well, you multiply when you see parentheses. You distribute here and you get this. Okay, cool. Let's keep going. We're not too much left yet. We got 2 problems here. If you've watched the whole video, I think I'll hope you just get it now. And maybe you can just try the problems. My guess is you probably haven't watched this video because hey, you want to try problems. You want to just do them on your own, which is great too. Although I think my explanations, if you want to take a step back, I think they do help. Anyways, this problem here, the way that I would do this problem, so anyways, let's just not get ahead of ourselves. Let's read what the problem is asking us. For each question below, decide whether it would be best to rewrite, look inside, or undo, then solve the equation, showing your work and writing down the name of the approach you use. Check your solutions if possible. So I might do this a different way. Right? You can kind of do you on these problems, but I will do it the way that I'm thinking. Okay, so try them all out on your own, and then maybe watch this video afterwards to see, did Mr. Form do it a different way? Was that easier? Does this give me ideas of how to tackle problems like this in the future? Because my way to do this is probably going to be different than yours. That's why it's helpful to know all 3 of the methods so that you can understand what other people are talking about if they're solving it, and also you can learn. Right? Well, this other person did it this way. That's faster. That's good for me. Okay. One thing I'm going to do here, I'm just going to make this a lot more simple. This is the way I'm going to do this problem. I'm going to set this up 2x minus 8. I'm going to do looking inside for this one. 2x minus 8. What would it have to equal? If it were being divided by 10 in this right side where happen to be equal to 6, what would our numerator have to be here? Oh, it would have to be 60. That's right, because 60 divided by 10 is 6. So that's how I would do this one. I would do looking inside for this one. And this is really just kind of saving one step, which is solving by undoing, because really what I'm doing even though I looked inside and just kind of logicked through it, really what I'm doing is I'm technically multiplying 10 by both sides. That's why I know that this can be true, but I also know it's going to be true just through logic. 60 divided by 10 is 6, so 2x minus 8 has to be 60. Add 8 to both sides. 2x would equal 68. Divide both sides by 2. X equals 34 would make this equation be a true statement. Let's keep going. Okay, again, do these problems on your own. Check this video out afterwards just to see if I did it differently. Okay, this one I'm getting a little lazy. I think on this one here, I'm going to solve by undoing on this one. You can really do it however you want, but I'm just not mentally there. I mean, looking inside is really easy. Now that I'm writing and doing it, maybe I should just looking inside. But anyways, just to see the difference, I'm going to undo the last thing that happened to x. Well, first, x gets divided by 3, and then 4 got added to it. So you start solving a problem by undoing the very last thing that happened to the variable on its side. So this is the plus 4. So to get rid of that, I'm going to subtract 4 from both sides. And then, right, we see here why looking inside is so close to undoing is because we get x divided by 3 would have to equal 5, which maybe if you did looking inside, you just knew that 4 plus 5 is 9. So that means x divided by 3 had to have been 5. All right, so x is being divided by 3. What's the opposite of dividing by 3? That's right, multiplying by 3. So you got to solve this one by doing the opposite, by undoing whatever's happening there to x, you undo it. You multiply both sides by 3, and then your results here, 3, and then x is being divided by 3, so that's going to cancel that part out. Our result here is that x equals 15 in this problem. All right, this one right here, well, let's just keep rocking on this one. Let's freaking rock this one here. Okay, we have a square root symbol right here, so we know that the radicands, this is called the radicands. This is a radical symbol. The root symbol is called a radical symbol. It looks radical, man. Dude, it's radical. Inside of that is the radicand, the quantity that's being square root, that's the square root's being taken of. It's called the radicand. And I'll write that up here, radicands, just because it's a good vocabulary word for you to know. Whatever's inside that square root symbol or radical. It's called the radicand. So we know that it has to be positive because you can't take a square root of a negative number. So, for instance, the square root of negative 36 isn't 6. But the square root of positive 36 is 6. So what I'm getting at here is the way I would do this one, again, is looking inside. We know it's going to be a positive number because we have a 6 over here, but we know specifically that 3x plus 3 has got to represent 36 because the square root of that would be 6. That's the only way we get to the 6 there. So let's do looking inside here. All right, so let's just do this. 3x plus 3 equals 36. Again, I could have done undoing and just squared both sides to get rid of the squared symbol, but I'm just doing looking inside because I think it's more simple. 3x equals 33 because I subtract 3 from both sides, and finally divide both sides by 3. This 3 coefficient of the x, right, just means multiplication. So if I divide, that's going to get rid of the 3 here, and we get x equaling 11, and we got our answer. All right, this one we saw recently here. This was on, I think, solving by rewriting, actually. So let's just go ahead and lock that in, that this is going to be rewriting into a simpler form. You know, actually, I'll argue here that this is by looking inside. Looking at how the variables are grouped. We're not actually rewriting this one because our bases. So remember, I would say that kind of rewriting is if you had to rewrite this with a common base. But here we have a common base. So this, we're going to drop the base. Remember that? Drop the base. And then, so dropping the base is kind of like looking inside. It's telling us that we know that these exponents need to ultimately equal the same thing. So we drop the base, and we would know that they would have to be the same exponents to make 7 to whatever power over here equal to, well, it's got to be 7 to the same power. So if we drop the base, we would get this, x plus 3 equal to 3x. And so I would argue that this represents looking inside, because looking inside, it says choose a part of the equation that includes the variable or multiple parts where all inclusive all occurrences of the variable, and then we got to say what it must be equal to. So just looking in this part of the equation, well, this expression needs to equal this expression. So we've kind of looked inside, and now we can solve this here. So we need to get x onto one side of the equation. So I'm going to subtract x here. So you want to take away the smaller amount of x's that you have so that the x's remain positive on one side. That's how I can decide between the 3x and the x over here. I'm going to get rid of the side that has fewer x's, and then I get 3 is equal to 2x, divide both sides by 2, and I get 1.5 equal to x. We're grooving here. We're grooving. See, make this a little bit faster for you guys here. Mr. Forden, why is this lasting so long? Let's do undoing. I'm just going, right? You can just go with whatever you think is going to be fastest at the end of the day. So undoing is fastest for me because, hey, that 4 is just hanging out. Oh, man, I don't want that 4 there. Start away from the x, the last operation happening to it. So you subtract there, and then I get square root of x equal to 5. And this is maybe part of the reason why I wanted to do undoing is because now I verified I'm going to have not an irrational answer. What am I talking about? I want to undo. I undid the 4. Now I need to undo this square root thing here. Remember, the opposite of taking the square root of something is squaring something. Remember, square root symbol is the same as taking x to the 1/2 power. So if we take something to the 1/2 power and we take that to the second power, 1/2 times 2 is 1. That's the way we can get rid of the square root symbol, or a 1/2 exponent. So I take both sides, we square both sides, and again, x needs to be a positive number. So I think we're going to end up with the right answer here. X equals 25. A square root gets canceled out by a squaring. And I did that by undoing the steps here. Okay, so we haven't really rewritten anything. Looks like we didn't really have any distribution. So we're not really solving by rewriting much at all, because in this one here, I'm going to, this is a tricky one here. Should I rewrite this one? Let's see. Maybe I'll rewrite this one, actually. Yeah, I rewrite this one because this is fraction busting here. So here, we're actually going to do rewriting. So we're going to use some algebra skills to make this. I'm not going to really focus on solving it right away, like isolating. When we mean solving means isolating x. I'm going to try to make the equation more simple, so it'll be easier to isolate x. And so that's solving by rewriting. What can I change this to make it easier just to then go and isolate x? So I'm not going to worry about isolating x now, but I know that what we have down here is a problem, the fact that we don't have a common denominator. So we need to think about what's the least common multiple of both these denominators here. And then we ask ourselves, does 3 go into 9? Yeah, it does. Okay, if one of the denominators goes into the other denominator, then you can just multiply this all by the larger of the two denominators. And then we're going to get 45 on this side. And that would have to be equal to, well, 9 times x over 3. Well, 9 divided by 3 is positive 3. So we would have 3x here. And then 9 times by 9 is 1. So we just left with negative x here. So we get 3x minus x equal to 45. Okay, so this is solving by rewriting just because we had to do a step first to clear up a problem. And then we can simplify and solve. So then we get 2x equal to 45, and then divide both sides by 2. I'm going to get a fraction as my answer. So 22.5 would be the answer, or x equals 22.5 if I want to write my answer this way. Last thing, consider the equation here. All right, we got last one, question 1052, and then we're done with this. So check your answers. This is what I got. Maybe pause the video, maybe fast forwarded. This is what I did. Email me if you have any questions. Ask any questions. Ask away. Consider the equation, the quantity x minus 7 squared equal to 9. Solve this equation using all 3 approaches solved in this lesson. Make sure each team member solves the equation using all 3 approaches. So I'll go ahead and write this down right here. So this is just kind of compare together, right? Compare what we got here. Okay, solving by rewriting means do the math out. And it looks like what we have to do to rewrite is that we have to deal with this whole thing, the binomial being squared first. So just reminders on that. If you're good with your perfect square shortcuts, great. If not, set up a generic rectangle. So what you're really doing with x minus 7 squared is not x squared minus 7 squared, right? It's the whole quantity, right? So the base of this square is going to be x minus 7, and the height is x minus 7. So remember, this is a binomial. It's going to become a trinomial on the left side of the equation. So let's get that now. X times x is x squared. X times negative 7 is negative 7x. And again, we have another negative 7x here as we do x times negative 7 again. And finally, negative 7 times negative 7 is positive 49. So we get a perfect square trinomial as a result, x squared minus 14x plus 49. And we see that structure. A reminder on that structure again about perfect square trinomials, that if we take the square root of the front term, we would get x. Square root of the final term could be negative 7, right? Because there's a negative square root of 49. Negative 7 times x is negative 7x, and then 2 of that, twice that. So this is a squared plus 2ab plus b squared is x times negative 7 times 2 would be negative 14x. It follows that format. A squared plus 2ab plus b squared is a perfect square trinomial. That's equal to 9. So now we're going to solve it using the methods we've done in chapter 9. X squared minus 14x equal to 40. Oops. Plus 40 equal to 0. And getting it equal to 0 is great because now we can, hey, we could have solved this by completing the square. That might have been a fun way to solve it. But in general, you want to factor whenever possible. And this one is factorable because if there are multiple ways to solve it, it's probably going to be a rational answer. So factoring is probably the way that I would do this to avoid problems. You can do a quadratic formula here too, right? When you had a standard form equal to 0, you could do quadratic formula, or you could factor it, right? And use zero product property. So zero product property to me is easier. Okay, so let's do this in our heads. A few numbers go into 40. Let's see if they could help add us to get to 14. So maybe 10 and 4? Yeah, 10 and 4 for sure. So we need to be negative too. So we need to get to negative 14. And if they're both negative, they would multiply to a positive number, which is positive 40. So this is what I get as my factored form of this quadratic right above. And then I can use the zero product property to get my answer. Okay, so I get 2 answers here because it's a quadratic. We expect 2 answers. And that's 4 or 10 is what I get for my answers. Cool. Let's see if we can do it through undoing. Okay, undoing would involve taking the square root. Okay, so undoing is taking the square root of both sides, x minus 7. And if we took the square root of both sides, we would have to have a plus or minus in front of whatever the square root of 9 is, which would have to be 3. Okay, so what we do in undoing, right, is we take the square root of the left side and square root of the right side. So we're introducing a square root, the side where the variable isn't, you add a plus or minus, and that's going to make the variable give 2 solutions to the variable in a second here. Okay, so to solve for this, right, we just need to add 7 to both sides, and then we'll get our 2 answers. All right, so x equals 3 plus 7, which is 10, or it's going to equal 3 minus, sorry, it's going to equal negative 3 plus 7, which is positive 4. So we get the same answers. Finally, looking inside, well, we might ask ourselves, what does this have to be to get us to 9? Well, x minus 7 to get us to 9, right? If this whole thing inside parentheses is being squared to get us to 9, then this is going to have to equal 3 or negative 3, right? There are 2 ways for a number to be squared to get to 9, and that's if that number were 3 or if it were negative 3. So you could just have started the problem out like that, and that might have been easiest for you. So what this part of the book does in this chapter is it's giving you permission to kind of start doing this stuff in your head. Which is kind of nice. You kind of developed the foundations to kind of get there, where we kind of trust you with doing it in your head going forward, at least. If you can see something that makes sense, you know it makes sense, then go for it. And you can check your answers afterwards. And that might be faster than doing rewriting, doing it all out. Okay, did we get the same solution using all 3 approaches? Yes. Well, and they don't ask why, so nice. Of the 3 methods, what do you think is the most efficient for solving this problem? Why? And I'm going to go with looking inside. And we're going to go with logic is faster than work. Well, let's put written work. So we save writing if we're looking inside. And to me, that feels faster, at least for me. And it might be different for you. You might find it faster if you're doing all the writing out, then that's fine. But looking inside involves just, hey, logicking through. What does this expression have to equal? It needs to be 3 or negative 3. So that allows you to write less than we did in the other approaches here. So we wrote about the same in this one. That's only because I didn't show the part where I introduced the square roots, which I probably should have done going through the undoing one. Cool. I think this worked out well. This might be the format that I do these videos in going forward, is just kind of having it open electronically like this, because we can go back and I can quickly show you everything that I did here. And I think this, hopefully, I was worried when we started distance learning if my handwriting would be really terrible, and I didn't want to make this feel like super distant, like we're on electronic forms, and not something you're used to, right? You're used to having the worksheets in class and kind of seeing what other people are writing. So I want to show what I was writing, but I think this was pretty successful. I think this is pretty clear. So feel free to email me if you actually want to hold on to this file. I'll hold on with the completed of this file. I have it, so feel free to email me if you want to see this a little bit more closely, and email me if you have any questions. All right, guys, looking forward to having more of these. We are 2 weeks away from ending the school year, guys. Not too far away. We might even be 1 week left, huh? Yeah, only 1 week left in the school year. Oh gosh, we got this. Chapter 10 is rolling along, and we should be able to finish this thing pretty soon this week. Take care, guys. Have a good day. Bye.